In this demo, I'll be showing you option combinators. Option combinators allow you to easily manipulate data and manage options. So far, we have mostly just been using match on the option type. There are many functions provided on the option type that make working with optional data a breeze. I'll be going over some of the more commonly used functions, but all are available at your disposal and are discoverable in the Rust standard library documentation. The first thing I'm going to do is create some optional data. We'll add some type annotations so we're able to see exactly what we're working with. And this will just be a value of 1. The first function I want to go over is called isSum. To access it, you type in the name of the option, followed by isSum. What this function will do is that it will check to see if we have some data within our option, and if we do, it will return true. If we don't have any data, it will return false. This is great if you want to determine whether or not you have some data. Next, we have isNone. So if we just change this to none, isNone will check to see if we have no data. So if we have no data, it will return true. And if we do have some data, it will return false. So this is just the inverse of isSum. So if you just want to know if there is no data, you can use isNone. Next, we have map. To use map, we just type in a.map, and map accepts a closure. The first argument is the inner value of our option. So in this case, it will be an I32. So we'll map a, we'll call our argument num, and then we can just take num plus 1. And that will add 1 to whatever number we happen to have. The great thing with map is it only applies if there is some data. So if there is some data, we'll take the data and add 1 to it. And if there's no data, then nothing will happen. Map is an extremely commonly used combinator, and it makes working with data easy since you don't need to check to see if you have any data at all. You can just write your function, and when you have data, it works. And if you don't have data, everything's fine too. Next, we have the filter combinator. Filter is used similar to map. It takes a closure that accepts a single function argument, which is the inner type of the option. In our case, it takes an I32, and the body of the closure needs to return either true or false. If the return value is true, then we'll keep the optional data. And if the return value is false, we'll throw away the optional data. So if we only want a number that is equal to 1, we can do so like this. It's also important to keep in mind that when you use filter, it borrows the number. So you'll need to borrow your comparison if you're doing something like this. So with filter, we have a closure that accepts a number. We're checking to see if that number is equal to 1, and if it is, we'll keep it. And if it's equal to anything else, we'll throw it away. When we throw it away, the return value will become none. And if we keep it, let's say that this matches, then all we do is return the same value that we started with. This is useful when you want to get rid of certain pieces of data that's within your closure. In our case, we are already mapped the data here, so this is going to throw the data away. And similar to map, it only operates if you have some data to begin with. If you already have no data, then this filter won't do anything at all because there's already no data present. Next, we have or else. To use or else, we take the optional data, type in .or else. Or else also accepts a closure. This particular closure does not use any arguments, so we can just use 2 bars to signify no arguments. And then we can just return nothing or something. So what this will do is, if A is already data, then nothing's going to happen. But if A is no data, then we're going to return some new data. So or else is used in the situation where you have no data, and you want it to be set to something no matter what. The last function I want to go over is called unwrap or else. So we can call unwrap or else, and then it accepts a closure that takes no arguments, similar to or else, and then we can return a default value. I'll return 0. Now the difference between or else and unwrap or else is that or else still returns optional data. So it needs to return some or none. And with the A or else case, since that's optional data, we'll still need to match on it later when we want to access it. When we use unwrap or else, it will actually take out the data and then place it within this variable. So this will no longer have optional data. If we started with some optional data and then called unwrap or else, the original data will be placed here. If A had no data, then when we call this function, this default data will be saved here. This is useful in situations where you have some data you want to work with and you have a default value that can be set if there's no data provided. Many times when working with different structures, you'll have optional data. So this can be used just to take the data out and then set a default when it's not present. I'm going to add some debug macros so we can see how this behaves when we change to different data types. So if we run this, we'll get a lot of information. So first we have our A, which is sum, so that's fine. We then have A is sum, so we know it's sum, so it's true. When we call is none, it's false because we have sum data. When we map it, our mapping function is the number plus 1, so it takes 1 plus 1, and then we get 2. When we call filtered, we're calling filter on A, which is 1 at the top. When we call filter, we still get back the same data because 1 is equal to 1. And when we call A or else, we still have the 1 because we have some data present here. Finally, the unwrapped data is just 1. Notice how it's no longer wrapped in sum because we just unwrapped the option. I'm going to change the original option to none, and we'll see how the output changes. So we start off with none. Is it sum? Nope. So that's false. Is none is now true. When we try to map it, we can no longer map it because there's no data, so we get none back. When we filter it, there was nothing to begin with, so we get none. Here we have A or else. So A or else, as previously mentioned, it takes the value here, and if there's nothing, then we'll take or else and have some data returned. So now that we started with none, we now have sum with a 5, because or else changed it to sum 5 since it was originally none. Finally, on unwrap or else, we started with none, and we attempted to unwrap or else. Since none was there, then we set it to the default value of 0, which is reflected here. These are just a few of the commonly used operations available on the optional type. As I mentioned, there's plenty more available in the standard library, but these are the ones that I've found to be the most immediately useful. This concludes the demo on option combinators. I'll see you in the next presentation.